All right, good evening, everyone. Let's go ahead and get started. Thanks, everybody, for coming out this evening and delaying your trip to the beer garden or whatever your evening plans are. Let's get our slides going here. So I'm Nick Benson. I'm a software development manager for Amazon Prime Video. I'm here with Chaitanya Salapakar and Harrison Clement, two of my colleagues. We're going to speak to you this evening about the partnership between Amazon Prime Video and Amazon CloudFront. The two teams have been working closely together for several years. And we want to share with you basically some of our learnings and hopefully some stories that will be helpful for you guys as you go off and build your own applications. So to give you just kind of an overview of what we're going to cover tonight, first off, I'm going to go into a little bit of detail about Prime Video, the Prime Video business case, how we use CloudFront, what our key objectives are in partnering with Amazon CloudFront. And then we have actually 5 examples or 5 sort of case studies that we'll go into a little bit more detail, where we talk about various AWS tools and strategies that we have made use of in different situations I think most examples are over the past year, but that's some interesting things to chat about there. And then last but not least, I will just wrap it up. Before we get going, I do want to mention to you all that the slides from this deck will be available on the SlideShare after the talk. And within the next couple of days, the talk will also be on YouTube. So if you see any designs or interesting callouts that you want to make note of for later, they'll be available. So Amazon Prime Video. We are a key part of the Prime experience with well over 100 million Prime customers globally these days. At Prime Video, we're all about premium video. So we take it really seriously that folks are kind enough to invite us into their living rooms. And what we're all about is delivering the best possible video streaming experience that we can for our customers. We're available globally, which presents its unique challenges as we deal with everything from the ultra-speedy networks, in the big cities in the US and in Asia to emerging internet infrastructure in places like India, Africa, and Latin America. And then also we deal with quite a large number of devices. By last count, several thousand different device types, everything from your mobile phones to embedded TVs to video gaming consoles. So really what we're all about is maximizing content, being on your devices wherever you are and whenever you want to watch. And as I mentioned before, being present and being available for customers also means dealing with a lot of different networks and different streaming conditions. So as we basically confront this diversity of devices, of networks, and even really of customer preferences, it becomes really important for us to anticipate what customers are going to want or what's going to make a great experience for customers, and then basically make the right trade-offs to produce the optimal experience for those customers. So when we think about trade-offs, we like to sort of map it out across 4 dimensions. The first of those is what we call reliability. So this is going to be propensity of a session to rebuffer, so the dreaded red spinner that folks see from time to time. And in the same category would be premature termination of session playback. If your app were to crash, you'd be kicked back to the main streaming screen of your video app. We call that a fatal error. That's actually in our taxonomy the worst thing that can happen in a streaming session. Secondly, we're concerned about video quality, and this is going to be are you receiving ultra high definition HDR, or are you getting dancing pixels on your big screen TV? Obviously, the latter is not a good thing and something that we need to be sure that we're avoiding. Playback start time is something that we consider. So when folks click play, we want them to instantly be immersed in the streaming experience. There's a trade-off there as we need to download the video and have it ready on the device before we can actually start playback. And then last but not least, this is a new trade-off that we're dealing with right now, which is time behind live. As we take on projects like Thursday Night Football, we did US Open in the UK recently, We're doing ultimate fighting every month. What we want to be really cognizant of is the fact that, we want our customers to learn about, the knockout punch or the winning touchdown from our service and not from Twitter and not from the voices of their neighbors echoing down the street. And again, this factors into this trade-off calculus as, the further the closer we are behind live, the less video we have buffering, the less video we have buffered, meaning we have the less tolerance to any sort of streaming or network disruptions. So as we rationalize these trade-offs and as we work to optimize and customize the streaming experience for customers, we use what we call at Amazon a virtuous cycle or flywheel. So the idea here is we basically have a closed-loop system where first we deliver video to customers. We collect all sorts of interesting information and telemetry about how the customer is engaging with the service, what network streaming conditions are like, what the performance of playback is like for that customer, and then how that customer reacts to the streaming experience. We feed that into a system where we perform analytics. In the case of CDNs, we will actually use this information to determine what the best CDN is for any given customer. So while we partner very closely with AWS CloudFront, we actually work with a variety of different CDNs, and we have set up basically what we like to call a free market economy of CDN competition where CDNs compete with each other exclusively on performance, so no advantage to CloudFront. We obviously partner very closely with them, but they're working to, just like all of our other CDNs, to maximize performance. And this data we use to figure out, by location and device, how we're going to divvy that traffic up. Similarly, we will use this data to inform the balance of trade-offs in the slide I showed you before, whereas, if we have a really fast internet connection, we want to lean in and show lots of HD. If we have a spotty internet connection, we want to quickly downshift quality or we want to buffer more upfront so that we can reduce the chances of a buffer for customers. And that's where the optimize step comes in. And then basically we just complete that cycle indefinitely. So that's sort of the high level of what we're about, what our objectives are in delivering video to customers. And to go into some more details of some of the technical challenges we're facing, I'm going to hand the mic off to my colleague Harrison here.
Thanks, Nick. It seems like we could all come in, sit crisscross applesauce in the front here, but thanks for coming out. So as Nick was saying, we have a lot of traffic that we have to manage. Just to kind of give you a picture of what that looks like, because we have a large and growing customer base, Sandvine actually measured us at almost 8% of downstream traffic in the Americas. That is a lot of traffic. In the EU, it's about 6%. And one of our key challenges, as you can see by this graph, which is basically a single day of traffic in the US. We don't get all this traffic at the same time. Unfortunately, I can't show you real numbers on what the peak is, but you're welcome to look at the Sandvine report. It's this percentage of all traffic, and they might have like a total in there, so you might be able to figure it out. So we have to deal with this peak, everything that we talk about in terms of capacity with our CDN partners and as well as our services really is focused on meeting or being provisioned to handle that peak load. So to give you an example of what that might look like over day, we've got the graph on the left showing our daily peaks. But what's interesting here is I've also added our Thursday night football traffic to these graphs. As you can see, it's a significant add. And so we have to partner knowing what our business is putting out there. We have to partner with our CDNs to help give them a heads up and maybe reserve capacity for special instances like Thursday night football. On the right, we see each dot representing a day of traffic. We have weekly peaks too. The The middle week is times with our Jack Ryan release, which is a video on demand release for a popular series of ours. So what's important, though, is that we keep in contact with our CDN partners so they don't throttle our traffic. And Chaitanya will talk a little bit more about how CloudFront manages that traffic. But we don't want to get our load shed by any of our CDN partners. So ensuring that they have a heads up. Like I said, we're generating so much traffic that a significant ad like what you see with Thursday Night Football, that's even more traffic than would typically be experienced by our CDN. So we work with them very tightly on this, and luckily they don't throttle us. Why do we work with so many CDNs? Like Nick said, they sort of compete in a free market economy for performance, but we also consider a single CDN to be a form of a single point of failure. So we won't want to put that out on our customers. So we work with CloudFront to be the best, but we also have other CDN partners that are extremely valuable. So one of the things that they do is not only do they cache our assets, our video assets, very large files, they're close to our customers. That way, latency isn't as big of a factor when they pull it down to their device, and they can actually use their effective bandwidth throughput to their device. So that's good. We also want to protect the AWS border by not having all of this content coming out of there and stacked unicast streams. So caching is super important. We consider it a performance thing, but also a protection thing for our services. Some of the ways that we leverage caching at CloudFront and other CDNs is we've developed a mid-tier for our live traffic. And with CloudFront, Chaitanya will get in a little bit about their regional edge cache that they build into every distribution. But the mid-tier will do things like collapsing requests. It will aggregate cache across different requesters. It could be they POPs or different CDNs. We try to minimize the cache key inputs so that those requests coming in all hit the same cached object. That's really important. This helps us reduce our cache space. And then with CloudFront, we're able to use a special set of distributions to cache our long tail content. This is our content that's not quite as popular, but it still needs to be cached so that not all of that content is pulled from origin. So on top of that, we also have services that are really important for protection. One of our key services is a service that dynamically customizes manifests, which are like the table of contents or index for any streaming video. We'll thin out bit rates. We will sometimes add in pre-rolls into the content, or we might have certain optimizations to get the best performance out of different CDNs. But we want to make these cacheable. So these are sitting at the edge, and that's reduced our scale that we need to provision for at our service layer, which really helps. We're also looking at experimenting with, or we've been experimenting with using Lambda and other compute to ensure that we can handle more and more requests at the edge and reduce our load into our core services even more. So we're looking at doing that with our manifest service as well as stitching in some ads or pre-rolls in the content at the edge as well. So Chaitanya, how do you guys actually manage all this?
Sure. Thanks, Harrison. So to handle Prime Video's scale of traffic, CloudFront has a global presence of POPs, or point of presence for short. So this basically consists of two types of locations. One is the actual edge locations, which are close to the viewer and have a cache. These are used to have a low latency connection to the viewer and do the connection termination right there, so that like TCP handshake or TLS handshake time is minimized. Now, we have numerous locations of this type all over the world. However, when the content is not present at an edge location's cache, it's a cache miss, that then has to go back to the origin. But given that CloudFront has a growing footprint, just in the past year, like at reInvent 2017, on the same slide, I had 100 POPs. And today we've grown to 150. So with that increase, we don't want an increased load on your origins. So that's the reason that we have a mid-tier cache layer called Regional Edge Cache, which helps by basically funneling the request to these nearby regional edge caches and then going onto your locations, going onto your origins. So these regional edge caches have a much larger cache width than any single edge location, and that helps protect your origins, plus as well as cache more and more of your content. So there are, there's all of this infrastructure in place, but what happens with the actual requests that clients send? So there are two stages of this. So first is the DNS resolution, which determines which edge location you reach out to, or rather a viewer or a client device reaches out to. So when a DNS resolution happens for either a CloudFront distribution name or a CNAME that you've associated with the distribution, so CloudFront performs in the vast majority of cases latency-based routing. What does this mean? Well, so CloudFront collects latency measurements from thousands of viewer networks, and this helps us determine what is the best POP in terms of latency for that viewer, and also how much load that's being brought on by viewers behind that network. So these factors, along with the capacity of the POP itself, tells us, hey, which is the best possible location to route the traffic. And once these calculations are done, we are able to predict what is the load on these edge locations and then direct the request there. So all of this helps us give a really good understanding of what is the steady state load. And this even accounts for variances during the week where evening times are more popular, like in the case of Prime Video, or for other download traffic, it might be overnight. Now, for a lot of events, the exact nature of the traffic can be unpredictable, and even when we know that there are big events coming, we see large increases in traffic which need to be handled. And this is a very fast increase, like in the case of Thursday Night Football, or even in the case of Prime original releases. So to handle this type of traffic, CloudFront has a fast-reacting flash crowd detector. And flash crowd is really this fast-growing surge of traffic. So you can see an example there, which is basically a Thursday Night Football game where the traffic increased about 8x in a really short span of time. And you can also see a nice little dip when folks have taken a break for halftime. But that picks back up, and then we see the traffic going down. So balancing this traffic out on edge locations is really important to ensure a good level of performance for the clients. Even with balancing the traffic across various POPs, there might be specific networks or links which might be overloaded. So CloudFront even detects this congestion and routes around it. Lastly, in addition to surges in legitimate traffic, we may also see surges in malicious traffic, which is DDoSes. So CloudFront has various mechanisms that automatically detects and mitigates these as well. Plus, there are additional AWS products and so on, like Shield, which can which you can use to enhance this protection further. Now, with this in place, once an IP has been handed out to an edge location, the client device uses that and reaches that edge location. So these edge location also have, they have TLS termination, and they have support for things like HTTP2 to service the viewer request. Now, to ensure that there's a consistent level of performance for different viewers requesting different types of content, we have load balancing for the various servers that are present. And so this helps us avoid any hotspots with regard to popular objects, or just right around any bad hosts due to bad hardware or any other reasons. Now, to ensure that there's not a lot of time taken up each time to set up connections, CloudFront also supports persistent connections. And this is really useful, like even in the video streaming case, where you don't want the connection to be set up for every single chunk that's requested. So CloudFront supports persistent connections on the viewer side as well as on the origin side. And for the objects themselves, you can have the full or the partial object request, where there's certain optimization for partial object requests so that we reduce the origin load. Now, one interesting case here is the collapse forwarding, which means when there are lots of concurrent requests for the same object, you don't want all that load to be seen on the origin server. So CloudFront basically collapses those requests and sends a single upstream request from a cache server. So what you see here is that collapsing is happening both at the edge location and the regional edge cache. So it's a sort of funneling effect where the edge location will send one or few requests to the regional edge cache, and with multiple edge locations contacting the regional edge cache, even the requests are even collapsed there. So you see fewer requests on the origin side. Lastly, with throttling, again, to ensure that there's fair use of resources, CloudFront also implements throttling so that all customers are using their fair share of resources and are able to get a good level of performance. Now, what's the result of all these mechanisms? Well, we've been able to grow hand in hand with Prime Video's traffic. So you can see over the past couple of years, we've grown significantly, over 6x the growth. And interestingly, that peak that you see is the Jack Ryan release that Harrison mentioned earlier. So you can see there's spikiness in traffic week over week. And for instance, this was one release that we spoke about. But there's a lot more that Prime Video actually delivers. So what does Prime Video actually have in all this traffic, Harrison?
That's a good question. You still hearing me okay? Yeah. So why all this traffic? Besides the number of customers, we also have the largest catalog available. That's not a boastful statement, it's just a fact. And we want to make sure that all of this content is available to whomever wants to watch it. So what does that look like from our catalog versus what people want to watch? Here is the curve that shows our popularity over our percent catalog viewed in a 3-day window. So this is pretty interesting. So this is just 3 days, but 90% of the streams in that 3-day period really only hit 12% of our viewed catalog. So you can see that's kind of, I could make this go even further, but that's a very, that slope is forever decreasing. At 60% of streams, that's less than 2% of our catalog. So we have some really popular content. The rest is long tail. But it's still, that 2% is a significant chunk. So we can't have that long tail be just origin traffic. We have to cache that as well. So how do we do this? Well, like I mentioned, our catalog is huge. You can get many offerings through subscriptions. That would be different channels. You can watch HBO through Prime Video, for example. And we offer many channels. There's TVOD, which is, I'm sure everyone's kind of done this. They look, see if something is free in one of their streaming services. If it's not, it might be available for random purchase through Prime. We also have a self-published platform where people can make content and submit it. So it creates a very, very large catalog. And then for each of those titles, we have to encode that, right? So encoding, we need to optimize for every device that's out there. And we support a large range. Some of the devices are really old. Some are brand new. They have different capabilities. So we have to make sure our encodes can handle all of those cases. So we have, we support 3 package types. So if you're familiar with video streaming, all video streaming today is done through different package types. We use Microsoft Smooth Streaming, Apple HLS, and MPEG Dash. We also have progressive download through MP4. So with those package formats, defining the protocols that we use, then we also support up to 22 languages for global content. So for one video, that can be about 300 files. That's a lot of data just for one single title, and you have a lot of options to get different titles. So problem here, CDNs can't cache all that content at the edge just due to the realities of disk space. They can only provision so much. They can't have exabyte storage embedded in every exchange and ISP out there. So we have to come up with creative solutions to deal with this problem. So one of our main strategies here, we like to split our catalog into what we call shards. If you're familiar with databases, similar concept. It's a horizontal slice of our catalog, each shard. So how do we actually split this? We have a couple main strategies here. We can do it by popularity, which we use with CloudFront. That way we can ensure that our popular content is vended on very highly distributed edges that are close to customers. Not as much space on those guys. So we like to put our long tail on a separate set of distributions that are maybe a little bit less distributed, but still pretty close to customers, and they can store a whole lot of data, so that really helps. Other strategies, we also employ strategies of sharding, consistent hashing based on the manifest URL. Like I was saying, when you go to play a title, you get a manifest. Here's how you get every single fragment in the title. And so like the URL for that manifest is really huge, and we can actually hash that and say, this key space goes to this shard, et cetera, and split that up. So the benefit of using this sharding strategy is, Chaitanya was talking about how the request actually gets to the POP. When your device actually wants to pull data from any of those CDN edges, it doesn't know how to connect to those edges. You have to resolve the host name. We usually think of DNS as this really basic thing, but in the CDN's case, it's really amazing what they do. But the beauty here is that if we are able to split the catalog into different shards and reference each shard by their own host name, then on the CDN side, they can actually control the resolution so that it only resolves to the IPs for the edges that actually have that content. So that's a easy way to leverage their DNS capabilities to empower them to cache a larger percentage of a very wide catalog. What does that look like at the edge?
So at the edge, what we actually see is the fraction of content that is being requested by all of those devices. Now, when those devices make requests with the different HTTP adaptive streaming formats that Harrison mentioned, so we see each media chunk being requested as an individual HTTP request. Now, during the course of playback, a video player can also switch representations, and that could depend on user choices, maybe in terms of languages that they want to listen to differently, or the video player is taking into consideration network conditions to determine what bitrate needs to be displayed at the current time. So this means that the different HTTP requests that actually come to CloudFront can vary in size as well as popularity. So when what this graph is actually showing is the actual demand profile for Prime Video seen over a day, and kind of gives the shape of how much disk space is required to serve a given amount of request bytes or network bytes, as we say. And so this demand curve, is affected by how many variants are there of the different titles that are present, as well as what is actually requested by the different players in terms of the manifest that is handed out to them. So beyond the requests themselves, there are also some configurations that can be set on distributions to improve the performance. So to start with, different types of objects are valid for different periods of time. So like a recorded video is valid pretty much for a really long time, so you can set it to the maximum TTL. For CloudFront, that's a year. On the other hand, you can have short-lived manifest. For example, that is live streaming manifests, which need to be refreshed every few seconds. So you set the short TTL on the order of a few seconds for such objects. And lastly, you might have dynamic objects, which even for 0 TTL object, which you don't want to be cacheable, it is useful to set a 0 TTL so that it can take advantage of features like request collapsing to reduce the origin load. Now, for each of these different types of objects, there can be variants in which take into consideration some of the request characteristics, like headers or cookies or query strings. And you can either use all of it or a subset of it or none of it. So, and depending on the use case, that can affect the cache hit rate of your distributions. So it's important to eliminate the ones that don't need to be a part of the cache key. And in addition to just caching the objects themselves, CloudFront also allows caching of errors. And this is really comes back to the point of protecting origin resources. So you can customize the TTL for this errors as well. And CloudFront can serve stale content in case the origin is unreachable. On the origin side, there are also a couple of other settings in terms of timeouts. And something we just announced last week was origin failover. So you can set up 2 origins for a cache behavior. And so in case one of them returns an error or fails, CloudFront can reach out to the other origin that's configured. Now, so this is a bunch of configurations which can vary depending on the exact nature of traffic that's being served. So Prime Video uses a number of these features. To start with, this configuration can be set at starting at different levels of complexity. So many customers start at the AWS console, where you can set, create distributions, create invalidations, set error caching TTLs and so on, and also view some data about your distributions in terms of metrics or reports. To make the task of this repeatedly either changing configuration or updating it in a programmatic manner, so AWS also has tools like the AWS CLI, and then you can also utilize CloudFormation templates to bring up AWS resources. And then taking it to the next level, the whole pipeline can be automated, where you take a bunch of template configurations and are able to bring up the required resources using the SDK or code build or code deploy tools. So given this outline, how does Prime Video really utilize this to serve the various configurations?
Yeah, so obviously we try to automate as much as we can. We're not too proud to use the console, if we have to. But I will show you kind of what we've been up to lately and what's been keeping us busy. All of these touch delivery in some way, so we have to, like Chaitanya said, we're creating hundreds, thousands of distributions. I'm going to focus on a particular example, and this is our live delivery at scale. We've created a platform for publishing live events and then connecting the customer to deliver the stream. This required, end-to-end automation all the way through, and CloudFront's capabilities that Chaitanya mentioned really came in handy for this one, and I'll explain. And I should also add that this is just one example, but we use everything that Chaitanya mentioned. Amazon CloudFront enables a lot of services to stand up and modify distributions. We use CloudFormation as well. We'll use the CLI sometimes. We also use Terraform. So, but in this example, we had a kind of a special case where we sort of had variability in the configurations that we didn't want to have to deal with in a manual way at all. So we have this publishing system that we're able to get a notification from with the specific parameters of the publishing outputs. We were able to get that notification through Amazon SNS. That goes right into an SQS queue. If any of you have worked on with these tools, it's a very standard workflow, super helpful, especially in this case. Because from there, we could just simply kick off a Lambda, because you can trigger a Lambda from SQS. Super handy. That Lambda then just goes and pulls out a configuration template that we're storing in S3, gets certificate info from certificate manager, and keeps track of all this build state in DynamoDB, which is really handy and actually saved us when there was an issue we had to deal with. So that's super straightforward, and anybody can build this with the tools that are available. And in this case, we're able to build the distribution and the Route 53 record that points to it. And that way, clients could talk to media tailor, elemental media tailor. And it came in handy, and we've built many distributions. The important thing here is that we're also monitoring failure cases. So in case we don't build it correctly or something goes wrong, we're able to monitor that with CloudWatch and get nice alarms. So at the end of the day, what we're after is to deliver a quality streaming experience to our customers. That's our main focus. And so the first part of that, we have to protect, not just the services at Amazon, but we want to protect our customers from the internet and all the fun, interesting things that the internet provides. It being a shared finite resource with no central authority, designed by humans. Things break all the time. So accepting that fact and dealing with it is hugely important to us. So we've enabled client failover on all of our devices to fail to different delivery paths. That could mean different CDNs, it could mean different origins and other components of delivery. We also have other intelligence built on our client. Nick sort of alluded to some of it earlier, but part of our optimization is that we are able to tune the adaptive bitrate heuristic on the device so that it has more intelligence to change bit rates when it needs to and get a really good experience for our customers, and that has huge impact. But what we'll focus here is our CDN selection. Some CDNs have more capacity at certain ASNs and POPs than others. Some CDNs don't have peering with a customer ISP, so that traffic goes over transit. Is that something we want? Maybe this other CDN has peering with that ISP, and maybe that deliver a better experience for our customer. So the point is that we don't want to go around and take manual measurements on what that capacity is or any other component that might affect a CDN's performance in a given set of conditions. So we've built something to do this automatically, and what we're doing, we are measuring CDN performance, and I'll get into what constitutes CDN performance, and then we're assigning weights to each CDN in a given segment to make sure that CDN is used the most in that segment. So this requires the measurement part of the virtuous cycle that Nick mentioned. We need to quantify user experience as best we can. The way that we're doing this is we are gathering all this data from devices that tell us raw data about what's going on. Is there a spinner? Did playback start? Did it stop? Did a user ask for it to stop when it stopped? We're getting all of this data at DDoS scale, actually. It's a huge amount of data. So we have to take that raw data and convert it into meaningful metrics or KPIs that help us quantify what the experience is. So we have a fitness function defined, and we keep trying to make it better, but it will calculate what the QoS score is, and that's what we're calling a quality of service score for a segment with a given CDN. What's a segment? A segment is just a piece of our customer base defined by 3 main dimensions. What device type are they using? An old smart TV might be a very different experience given the same everything else than say like the latest iPad or something. So we have to factor that in. We also have to factor in the ASN and the customer location. So what network are they on and where are they? So we have thousands of segments out there that we're constantly comparing CDNs. It's a fair comparison because we believe that we've isolated all the variables or control for all the variables that might affect performance that are outside of the CDN. So to do this, we've built a pretty large pipeline. It starts with our stream processor. This is a service that our data platform teams built that basically is scooping up all that data or getting all that data from all the devices and parking it in S3 for us. And this data is session segmented data. So every session that's out there, that session has unique data in our stream processor output. So then we have an EC2 fleet to take that data, filter out the bad data, and then throw it to Kinesis Analytics. which is really helpful because the session data, which is when a customer is watching a title, we're not as interested in that as we are into segment data, because the whole purpose here is comparing CDNs. So we're able to aggregate this data into segments using Kinesis Analytics. From there, we're using DynamoDB to have 3 main tables. These are different time window-based tables that where we're looking at 5-minute data, we're looking at 15-minute data, we're looking at hour data, because things happen on different scale. There might be an ephemeral issue that lasts 5 minutes. The steady state, though, is better represented in an hour. So how do you weight those? And that's part of our fitness function for figuring out which CDNs are the best. So we take that data, we break it up into different segments from Kinesis Analytics, store in Dynamo, and then we have a consumer that is pulling that data, this is in EC2, and computing that into the metrics or KPIs that I mentioned earlier. So we're getting things like, what's the latency, what is the zero root buffer rate, and we're putting that into another set of temporal tables that, luckily, we're using that same notification and SQS workflow again. Once that metric data is actually computed and in these other tables, we're able to pull that from another EC2 fleet to actually make decisions. The decisions are really part of, probably the core part of our algorithm. How do we shift traffic and when? It has to do with how do we weight different metrics against each other, and what is the aggressiveness that will shift traffic? All of that is really the biggest part of our pipeline here. We're triggering that on a regular cadence using a Lambda, and that Lambda, it can be triggered by a CloudWatch. That's generally how you trigger time-based Lambda executions. That Lambda will then have the data pulled from this fleet that's actually computing the decisions, and then we throw the weights into another table. Once those are in there, we generate a new policy, again kicked off by a Lambda, and write that into S3. And why do we do that? It's there in S3 because we have another service that at URL vending time, so this, when I was talking about the manifest URL earlier, when a customer goes to play a title, they need that manifest URL to kick things off. There's a whole series of events that happen when they go to get that manifest URL, including referencing this policy that's written into S3 and built from this whole pipeline to say, like, okay, you're in this segment. We want to probabilistically send you to this CDN first, this CDN second, et cetera. So with that and the other strategies, we're working with CloudFront to make them better. And in fact, it's really useful when we see our balancer making decisions that are awarding CloudFront less traffic. So just visually, here's a case where we have our zero root buffer rate actually looking real bad, and CloudFront is losing traffic. The measure of traffic there is those pink steps. And so, this is something that we wanted to make better. We knew that something was like legitimately wrong. So, we told CloudFront, and how did you guys actually fix this?
Yeah, so I think based on what Harrison said, that we look at different segments. So the first step was to look at the segment and look at what factors play into this. So looking at ensuring that we have network capacity to be able to handle this traffic, and ensuring that there were no congestions, and ruling out those factors. So in this instance, we were able to rule out that it was not any provider-related or any network layer-related issues. And that led us to looking further into the server-side metrics and server performance. So what we found out behind the scenes was, in many cases, we were being quite cautious about handling popular objects or dealing with any hotspots in terms of server load. And over time, we had increased performance of the different servers. So using like system tuning parameters or improving our caching policies. So that means that we did not have to be as cautious for the load balancing factors. And once we were able to tune that further, we could improve the experience for the devices and reduce the rebuffer rate significantly. And that, in this case, allowed us to win traffic. So you can see week 4 onwards, we were able to win traffic in the segment. Now, to help us narrow down on this issue, not only were the client-side metrics useful, but Prime Video also used a number of server-side metrics that CloudFront provides. So what are really these metrics? And these are available for every CloudFront distribution. To start with, CloudFront publishes metrics to CloudWatch, which includes metrics on requests or bytes or errors. Now, these are published near real time, so they can be used to understand the operational health of your CloudFront distributions. For a slightly longer term view, CloudFront also publishes reports which give an idea of the usage of distributions in, again, requests and bytes, which are like the basic parts of serving traffic, but also some more higher cardinality data, like what are the popular objects or browsers that are accessing your distributions, as well as what is the exact HTTP status codes. So these are available in the console, and some of the reports you can even export to CSV and play around that in your own tools. So this gives a pretty good high-level perspective, but for the case that we covered, we had to go deeper into understanding what is server performance seen from the devices. So CloudFront also publishes request logs, and so these logs are gathered from all the edge locations and then published to your S3 bucket. So that's an example of a request log line, and that indicates where the request was served, how long it took to serve, for which object it was, and there's a bunch of information there which is described by the fields. One of the key ones highlighted there is the X-Edge request ID, which uniquely identifies a request. So in case you have to reach out to CloudFront for a further deep dive into this, having those request IDs definitely helps us pull up even more information on the server side. So given the scale of lots of customers like Prime Video, there can be lots and lots of logs. So it's probably tedious to go through all of them, and it helps to have a tool like Amazon Athena. For instance, this is just one tool, but many partners also have built tools to take these logs and digest them and create nice dashboards, whether that can be in Amazon QuickSight or in any other partner tools. So this can help narrow down on, hey, which requests were errors or which requests saw a higher amount of time taken, and can allow you to slice and dice the data by which edge locations served a specific type of clients as well. So with all of this, the main focus is to improve customer experience, and CloudFront is happy to provide as much data and take this to improve customer experience and ensure the highest quality of video delivery that's possible. So with that, I'll just hand it back to Nick to wrap it all up for us.
Thanks, Chaitanya. So just to kind of close things out here, sort of core takeaways from the talk here. Number one is, just want to re-emphasize the importance of taking the time to just understand your customers, understand your traffic base. I think that, really digging in, understanding both traffic profile as well as, the nature of the content that you're serving. At least in our case, that's really served us well. Separately, I think, taking the time to understand the variety of different tools and techniques that are available for, standing up distributions, standing up different AWS components, and managing these different workflows. You'd be amazed with, how something seemingly as simple as standing up a CDN configuration can become part of, very complicated workflow depending on your use case. And AWS, the different tools that we've been able to use has made this very straightforward for us, enable us to ship products in timeframes we wouldn't otherwise have been able to meet. And then last but not least, I think, just the rich metrics that are available from CloudFront, especially the logs. Those have been real lifesavers for us at Prime Video, just to understand, how our service is performing, how customers are interacting with our service. I think, it's sort of an overlooked resource, I think, and we highly encourage you guys as you're building applications to take advantage of these resources. So that concludes our talk for this evening. We've listed down a few talks related to this session. I think a couple of these at least are over. The third one here, workflows with Amazon CloudFront, that's tomorrow. These should, I believe, be available on video as well, and you can get the slides off the website. They're just relevant to what we've been talking about today. Highly encourage you to check those out. And then last but not least, we will be hanging around for the next few minutes. Happy to answer any questions you guys have if you want to just kind of, come up after we're done here. And then finally, please take your time to fill out the survey. We scrutinize these results really carefully, and we use them to, figure out what sorts of talks we're going to give next year. So thank you all for coming, and have a great night.